In our next section for UCS LAN connectivity, we're going to talk about the virtual NIC templates and then how we can apply these to multiple service profiles at the same time or multiple service profile templates that allows us to make a single change, like if we want to add a VLAN to the servers, that we don't have to go to every individual instance of the virtual NICs and then apply that to the individual service profiles that are bound to the individual servers. So before we make any changes, let's take a look at what we have currently configured on the GUI. So we're going to go under servers and then under service profiles, and we see that we have two different profiles configured. We have Brian underscore profile 1, Brian underscore profile 2, and then each of these have separate virtual NICs. So we have ETH0 and ETH1. So if we take a look at the first profile, first NIC, this is pin to fabric A that has fabric failover enabled. And then if we go to modify VLANs, we can see that we have VLAN 20 assigned, and we're using VLAN 20 as the native VLAN. Now, the issue that we would run into here is that assuming down the line we add a new virtual machine that's going to be in a new subnet, it's going to be in a new VLAN, it means that we would need to create the VLAN in the UCS, we create the VLAN on the layer 2 switches, and then we have to edit the individual virtual NIC to make sure that that VLAN is allowed. So unlike trunking on a regular Nexus, Catalyst, or the FI northbound, when we create a VLAN globally, it is not automatically trunking southbound to the blade or southbound to the vNIC. And notice here that when we're modifying the VLANs, there's no checkbox to say all VLANs. You'd have to check them individually to say what numbers that you want to have in the allowed list. So from an operational point of view, it makes more sense to do this from a template as opposed to individually. It's going to cut down simply on the number of programmatic changes that you would need to make from the GUI, from the CLI, or potentially from the API calls. Okay, so next thing we're going to do is we're going to create a template. We're going to create two different templates. One is going to be for the A fabric, one is going to be for the B fabric, and then we're going to replace the actual instance of the NICs of profile 1 and profile 2 with these templates, and see what happens once we actually boot them up, make sure that we have connectivity, and then look at what happens when we make changes to the templates, how those are going to affect the individual service profiles. So specifically to define these, we're going to go under the LAN tab, and then we're going to go under the LAN cloud, and then we're going to go to actually not under LAN cloud, it's going to be under I want to say policies towards the bottom, and then we have our vNIC templates. Okay, so we're going to right click, we're going to create a vNIC template, and first thing we do is give it a name. Okay, so we'll say that this is going to be our, let's call this vNIC ETH0 Fab A. Okay, let's say Fab A with failover. Fab A with failover. Okay, so this is going to be on Fabric A. We're going to enable Fabric failover, which again assumes that the network card in the blade or the standalone server supports it. And then under VLANs, we're going to create additional VLANs. Okay, so let's say in addition to our management VLAN, which is number 10, we're going to create data VLANs. So let's say we're going to call these prefix data. And then the VLAN IDs, let's say that this is going to be 11 through 19. Okay, previously we had VLANs 10 and 20 in addition to the default VLAN 1 defined. Okay, so when we're creating a range of VLANs, or notice that here you could put a comma in between them, when it creates the VLAN, it's going to append the VLAN number onto the name. So these should say, let's call these actually data underscore VLAN. And this should be created as data underscore VLAN 11, data underscore VLAN 12, all the way through number 19. Okay, so what I'm now going to do here is to check the management VLAN. We're going to leave this one as the native VLAN, so that's untagged down to the OS. And then we're also going to include 11 through 19. Okay, so notice that we need to check these individually. Okay, so we have 11 through 19. And then VLAN number 10, VMware Management, is going to be the native VLAN. The other options down here, we're going to come back to QoS a little bit later, but at a minimum what we need to define here is going to be the MAC address pool. Okay, so we're going to call from the default pool and then leave the rest of these alone with the exception of the network control policy. Okay, the network control policy, I'm going to leave the default option, but we're going to modify the default network control policy. What this mainly is going to be used for is enabling CDP down to the OS level. Okay, and it'll make a little bit more sense in a minute here why we want to do this. It's going to be for visibility from the VMware vSphere client, so we can see how the vMNICs are going to map northbound to the vNICs on the UCS side. Okay, so technically we don't even have to select the default dropdown here because it's going to be using default automatically, but just wanted to show that that is explicitly going to be used. Okay, so we have our template for ETH0 on Fab A. We're going to right-click this again and create another template. Okay, so same naming convention. We're going to call this one ETH1. ETH1 underscore Fab B as in Brian with underscore failover. Okay, so this is on Fabric B. This is going to have failover enabled. And then this is going to be an updating template. And actually the other one I have to go back and change this from initial to updating. I'm going to add the VLANs, so check which VLANs that we want to add. Okay, so 11 through 19. And then the management VLAN, this one is going to be native. We assign the MAC address pool, going to be using the default pool that I had previously defined. And then everything else is going to have default, okay, including network control policy. Okay, so let's go back to the first template, ETH0 Fab A with fail. And I'm going to change this to an updating template. Okay, what this means, updating versus initial, is that when I actually go to spawn virtual NICs from the template, and I go to make a change, it's asking me, do I want to make the change on the template itself and then push that down to the instances, or do I want to have to make the changes to the individual NICs themselves? By default, when the template is initial, it means it copies the attributes from the template down to the instance, but if you update the template, it's not going to update the instance of that template. Okay, updating template means that it will make the update. So the vast majority of times you would want to check this box, or you hit this radio button here that says updating template. Mainly what this is going to affect in my case is that if I want to add additional VLANs, down the road I would have to only update the vNIC template, and then it would push these changes down to the individual OSs. Additionally, the change of the VLAN numbers is not a disruptive change, so it does not require reassociation. Yeah, a number of these other changes, like if I was to change where the fabric is pinned to, enable failover, those would be disruptive changes. Those would require reassociation. Okay, but the VLAN numbers themselves do not require it. Okay, so this is now an updating template, and we're now going to create some instances of this. Okay, so let's go back to our service profiles, and what we're now going to do is to delete the NICs that I had previously created. Okay, it says this is going to cause some problems with reprovisioning. Additionally, this is going to cause us to have to re-acknowledge. Okay, because deleting the NIC, it's like physically unplugging the card from the bus, requires us to do a reassociation. So we're going to delete the NIC. Yes. And then we're going to add new NICs. Okay, so we're going to add a vNIC, create a vNIC. We're going to call this ETH0, and this is going to come from a template. Okay, so notice here that you could have also created the template here. There's a number of places to do the same thing through multiple navigation paths in the UCS Manager. Ultimately, they're all talking about the same objects. So whatever way that you learn, just stick with it. There's no one way that's better than the other. Okay, so this is the name of the NIC is ETH0. We're using a template. Specific template is ETH0 Fab A with fail. Okay, notice that the other options I don't need to set. Okay, there is also an option for the adapter policy. This basically controls the OS specific options. Like there's one for Windows, there's one for Solaris. What this ultimately controls is the stuff like, is the TCP offload engine enabled? Am I doing checksum offloading to the hardware card? Normally you would want these options on because they do support hardware acceleration for them. But for some reason, in some cases, the OS wants specific options for these, like what's the transmit queue size, what's the receive queue size in terms of the buffer depth. Normally you just leave this as the default. Okay, but that's what it's talking about here, the adapter performance profile. It has to do with the individual OS settings. Okay, so I created ETH0. And then we're going to do the same thing for ETH1. So we're going to right-click this again, create a NIC, create a vNIC. This is going to be ETH1 that is using template ETH1 Fab B with failover. Okay, same thing is going to happen to the other profile. Okay, notice here additionally that we have the vNIC VHBA placement policy, where it says that ETH1 is going to be in the actual order number 2 after NIC ETH0, which is what we want. Okay, we want to make sure that ETH0 is going to become vMNIC0. So it needs to be placed on the bus before ETH number 1 is. Okay, otherwise we could create a LAN connectivity policy that would specify this, or we could create a dynamic NIC connection policy, okay, or modify the placement. Okay, but by default, the system itself is going to choose this, and we do care about what this order is. Okay, so just to be 100% clear on this, I'm going to modify the placement policy, and then I'm going to create a placement policy. Okay, so we'll say that this is going to be for, actually no, we'll just specify this manually. Okay, so I want FC0, FC1 first, then ETH0 next, ETH1 after that. Okay, normally you would define this in your service profile template, but we'll look at that a little bit later. Okay, so actual order, ETH0 is going to be first, and then ETH1 is going to be next. Okay, same thing we need to do on profile number 2. So we're going to delete these NICs. Okay, that's going to cause, it says it causes re-acknowledgement, but we're going to acknowledge after this is done. Okay, so while I'm editing profile number 2, let's go ahead and acknowledge profile number 1. So let's go up to pending activities and then select which profile this is. Okay, profile 1. So we're going to check reboot and then apply. Okay, so we still haven't acknowledged profile number 2 because I'm in the middle of making changes to that. So on profile number 2, we're going to add a NIC. We'll call this ETH0. This is going to be template ETH0 fab A with failover, apply. Then create another NIC. Create NIC. This will be ETH1. Okay, ETH1 is using the template that is ETH1 fabric B. Okay. Then we're going to update the placement policy. So under the profile, we're going to go to the General tab. Okay, so profile name, General, then down to Modify vNIC VHBA placement. And we're placing the NICs manually. So we have the storage adapters 0 and 1. Then we're going to have Ethernet adapter 0, Ethernet adapter 1. Okay, 1, 2, 3, 4. This is going to make sure that we have these numbered as vMNIC 0, vMNIC 1 from VMware's point of view. Okay, then finally we're going to acknowledge. So under pending activities, we'll say acknowledge all, and then OK. Okay, so lastly, let's go back to the KVM, and we should see the servers rebooting. Okay, so slot number 5 is rebooting. Slot number 4, we should see this in a second, is going to start to reboot as well. So again, anytime that you make a change that requires reassociation, keep in mind that this is going to take like 10 minutes for this actual change to be applied. So let's let this sit and then fully boot, and then we'll come back in a second here once the system is ready to actually send packets. And we should be able to see this from the IP connectivity point of view, whether we have connectivity to this address or not, the 10.0.0.102. Okay, right now it should be failing because notice now the server's rebooting. So we'll come back here in about 5 minutes once the servers are done fully booting. Okay, so now both of the servers are booted back up, and we can see we have IP connectivity to the 10.0.0.102, which VLAN 10 is now being used as the management VLAN. Again, as we saw from the vNIC template, that was being marked as the native VLAN, which means from the hypervisor's point of view, from VMware point of view, we don't need to tag a VLAN number onto the VM kernel, which is their management IP. So if we were to go over to the second segment, so if we ping to the 20.0.0.101, notice that currently we do not have connectivity to this. The reason why is that the native VLAN on that server is VLAN 10, and the hypervisor is not set up to use VLAN 20 for tagging. So basically I have two different options now, assuming that I want IP connectivity to both of these segments. Either I could go to this server and tag VLAN 20 for management, or I could change the IP address so that is in the VLAN 10 subnet. Okay, ultimately the final change I'm going to make is to renumber it, but I want to show just briefly how you would set the tagging, assuming you didn't want to use the native VLAN. So we would go hit F2 to customize. Then again, password is CCIE DC01 with a capital C in the beginning. F2 to customize. We then go to configure the management network. Okay, configure management network. And then under VLAN, we're going to set this to VLAN number 20. Then escape. Apply, yes. We should see ideally that we should start to get IP connectivity down to the host. Okay, so let's escape out of here. And actually, no, you know what? VLAN 20 is not being tagged. I would have to, actually, this is a perfect example. So let's go back to the UCS manager. What we're going to do is update the template so that VLAN 20 is going to be added. Okay, so let's go to the LAN tab, and I'm going to delete VLAN 10 or VLAN 20, and I'm going to rename it. Actually, I don't even think I need to delete it. I think I can just change it. So let's go to LAN Cloud. Then under LAN Cloud, under VLANs, and then VLAN 20, let's see if I can rename this. I want to call it data underscore VLAN. No, I can't. Okay, so I'm going to have to delete it. So let's delete VLAN 20, yes. Then I'm going to create a VLAN. Okay, we'll call this data underscore VLAN 20. The ID is 20. Okay, when you create an individual VLAN, it's not going to automatically append the number onto the name, only if you're creating multiple. So if I said 20 to 30, the naming of these would be data underscore VLAN 2020, data underscore VLAN 20, 21, 22, 23, etc. Okay, so I want to create only one of these. Okay, this should now create it. So I have data VLAN 20, okay, it's created. And then if we go back under LAN policies, under the vNIC, we're going to modify VLANs, and I'm going to add VLAN 20 onto this. Now notice that when I click OK here, what it's not telling me is that I need to re-acknowledge, because this is not a disruptive change. So I'm going to add this to both Fabric A and Fabric B. So let's say modify VLANs, check number 20, and then OK. Okay, ideally the end result of this should be that we should shortly regain connectivity to VLAN 20. Okay, there was an error message that it threw about the uplink, so let's go to the service profiles and let's see if there's any error codes, any faults on them. So under server service profiles, it says status is okay. Let's look at the faults. And it says ENM source pinning is down. So let me see if I can clear these and see if these are still. So acknowledge the faults. And same with profile number 1. Okay, so let's go to faults, and let's say all faults. Let me try acknowledging all of these. And we'll see which. These faults will be removed if they're acknowledged and cleared. So I want to know which ones are actually cleared. Acknowledging them is just saying, yes, I saw them. Okay, so let's go back to profile 2. Let's go to all faults. Right-click. And then which ones are not acknowledged? So I think once you do acknowledge it, you can't check it again, which is why this is grayed out. Okay, let me sort it by severity. So the green ones, we can acknowledge those. Those should clear out. The rest of them are going to, the rest of these are probably going to stay. Okay, it says virtual interface link state is down. So let's check the northbound network. I may have some of these interfaces still shut down from our previous example. So let's go to 5K1 and 5K2 and look at the show port channel summary. Okay, 9 and 10 are down on this side. So let's go to interface E1 9 to 10 and no shut. And then on 5K1, this should be port 11 is down. Okay, E1 11, no shut. Okay, the end result is that the fault should now be cleared. Okay, so you can see they're disappearing there. And then the same should be true under profile 1. Okay, so some of these don't relate to what we're dealing with now. It says that there's some other problems like the local disk is missing. This means that there was a storage connectivity policy that was trying to use those local disks, but it's not actually plugged in. Log capacity on the management controller is very low. Okay, so I could clear the logs in order to fix that. But basically these are low severity. Okay, I don't really need to worry about this. What I'm mainly looking for is any of the red circles with the X in them, or this upside down triangle, the orange one. These means that either that something is physically wrong with the box, like the power supply failed, or usually if it is this orange one, which is severity major, major normally is something that you configured wrong. Okay, like the VLAN is not matching on the trunk, something like that. Okay, so let's see now, do we get connectivity to the other management NIC? No, we don't. Okay, so let's go to, let me clear the ARP cache, ARP-D star, and let's go to the upstream switches. We should be able to ping 20.0.0.254, which is the default gateways of the 5Ks. Okay, which we can. So we can ping the gateway. Let's see, can we ping .101? Not yet. Okay, so let's go to the 5Ks. We may need to clear the cache. So let's say on interface VLAN 20, shut, no shut. Okay, that'll delete any of the old entries. Let's look at the show MAC address table for VLAN 20. And we should see that there are some addresses that are learned towards the end host. Okay, which we are. So let's look at the show IP ARP and ping to 20.0.0.101. There we go. Okay, so we now have connectivity to the new management address. If we look at the show IP ARP, pipe to include 20.0.0.101, we see the MAC address. If we look at the, on all four of these, so the 5Ks and the UCSFIs, let's look at the show MAC address dash table, pipe to include that number. Whoops. Pipe to include, what was the number? This 0001. This should be in VLAN 20 on one of the vETHs. Okay, so we need to connect to NXOS, then look at the MAC address table. So it's not on fabric A, we should see it on fabric B. Okay, so it's being learned in VLAN 20. Okay, this is going to be the actual instance of the management IP. So again, basically two different solutions for this. If we look at from the CLI and then look at the show run on the vETH, show run interface vETH 715, this is basically just a trunk that's going down to the access layer, down to the blade. And then based on the radio button that we're choosing on the vNIC template, which VLAN is native, the end result of that is the same exact command as we would have on regular Nexus or Catalyst, which is switchboard trunk native VLAN. So it means VLAN 10 is untagged to the host, but it is being tagged northbound on the uplinks. So if we look at the show interface port channel 1 trunk, or show interface trunk, and then we'll look at port channel number 1, or actually 101, show interface port channel 102 trunk and 101 trunk, we should see that the VLANs are forwarding because we're not limiting any of these. Show interface port channel 101 trunk. We're not limiting any of these based on the VLAN groups or under the VLAN manager. Because again, in this case, we do not have a disjoint layer 2 network. We have a single logical port channel that's going up to both 5Ks, which again is the simplest LAN design. We don't need to worry about where's the dedicated broadcast receiver. We don't need to worry about any of the pinning of the NICs because they're all going to dynamically pin to these uplinks. Okay, so again, from this vEth, we have VLAN 10 configured as native, which means that when we go down to the OS level, the OS has to be listening for that tag. And how I configured that from VMware's point of view was to go under the management network, and then I told it what particular tag that it was using. Okay, the other option would be, instead of tagging the VLAN on management, we'll go to configure the management network. We're gonna go to the VLAN, which right now is 20, and we're gonna delete this. Okay, so it's untagged. Then I'm just gonna change the IP. Okay, so it's 20.0.0.101. I'm gonna change this to 10.0.0.101. 10.0.0.101. Gateway is now going to be 10.0.0.254. Okay, so we now have two hypervisors, 10.0.0.101, 10.0.0.102. And we should be able to reach now both of them. Okay, next thing we're going to do is actually manage the hypervisor. So we're going to go to the vSphere client, which you'll see on your jump boxes if you're doing this from Rack Rental. So let's go to 10.0.0.101. Username is root, password is CCIEDC01. And what we're now going to do is to create a segment that we're going to use for the actual virtual machines, which could be anywhere from VLAN 11 to 20. Okay, those are the ones that we're tagging down on the vNICs. Okay, so next thing we're going to do is we're going to add a VM. Okay, so right now we have just the hypervisor itself. It has no virtual machines running on it. So we're going to go up to File. We're going to create a new virtual machine. Okay, this is going to be a Linux box. So let's say typical. It's going to be, let's say that this is Linux -001. Okay, give it a name. Give it a data store. And then this is going to be Linux, and we'll say Linux Other. Okay, Linux Other 64-bit. We're giving it one adapter, and let's say virtual disk size is just 1 gig. Actually, I don't even need that much, so I'm going to do a thin provisioning, 1 gig. And then finish. Okay, so I'm going to edit the virtual machine settings, and I'm going to attach the installer. So CD drive, I'm going to attach a data store ISO. Okay, so I'm going to need to upload the ISO to the data store. So specifically, the ISO is going to be on your desktop under the lab files. Okay, so lab files, ISO, Linux. And then it's this damn small Linux DSL. You can see that it's only 50 megabytes is the installer. So it's a very, very lightweight image. It's basically for just doing a quick provisioning of a virtual machine. Okay, so I'm going to upload this to the data store. So the way I'm going to do this is to go under the host. Under the host, under configuration, under storage, I'm going to right-click the data store and browse. Then I'm going to upload a file. File is on Z, lab files, ISO, Linux, and then the ISO image. Okay, should pretty much happen immediately. Okay, it's very, very small, 50 megs. Okay, so I have the installer. Now I'm going to attach this to the VM. So I'm going to go to the virtual machine. I'm going to edit its settings. Go to CD drive. I'm going to map this to a data store ISO. And then this is going to be under data store 1 under this Linux image, 50 megs. Okay, then power it up. Okay, additionally, let's open up the console. So this is a live CD. It should boot right into Linux. And under CD, we should see this as attached. Okay, connect to ISO image on the data store. This one here.